To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the earlier chapter, we got an idea about the simple machines and we discussed about the main types of simple machines in the earlier chapter. And we identified the four main types of simple machines, my dear children, as the lever, inclined plane, wheel and axle and the pulley. So within this chapter, my dear children, we'll be discussing about the first main type of the simple machine, which is the lever, right? So we'll be investigating several facts regarding the lever and the special things regarding the lever. And also, like I said, when we are discussing about the previous chapter, I told you about there are different kinds of levers according to their structure, right? So we'll be discussing about the types of levers as well within this lesson part. Right, then now let's head on to see the first main type, right? The first main type of simple machine, which is the lever. So here it is given, as we have discussed earlier, metal rod or else a crowbar can be used to lift a wooden log or a rock. Let us consider it again. So can you remember, my dear children, we discussed how to lift or how to remove a certain rock or else a wooden log by using a crowbar. Okay, and over there we discussed about how to utilize the instrument called as the lever. That's the simple machine, right? So by using the lever, we have moved it to a different location. Especially we did a simple experiment within our laboratory in order to give out a certain idea for you guys about this lever process. So now we are going to consider it once more. As you can see, we are within given figure. Now a person is over here. Now he's going to move the rock which is over here by using the crowbar. So let's see. It is difficult to lift the rock to the same height. The force that should be applied to do this is very large, that a single person cannot do it. It is easy to lift the rock or the block by using a crowbar as a lever. So as you can see here, like we discussed in the earlier chapter, my dear children, it's very difficult to move this it is very difficult to move this log or else the rock by our own. I mean, we have to apply a greater force. So when you are lifting this thing, if you are need to lift this thing to a certain location, my dear children, then you have to apply a certain force which is equal to the weight of this particular object, in here the rock. Okay, so you need to apply a force which is equal to the weight of the rock, then you have to move it to a different location. That's how the that is how the like lifting process is going to work. But however, my dear children, if you are using a crowbar, right, by applying a very lesser force, we have the ability to move it to a different location. Okay, we discussed that thing in the previous chapter in detail, right? Then why did the lever make the job easy? So why moving like this is going to make our work easy? I mean, like, what is the reason behind the making the work easy by using a lever, right? By using a lever, what is the benefit that we can obtain? So by using the lever, the benefit that we can obtain can be investigated, my dear children. So now our aim is to investigate about that process. So let us do an activity to find about this. So now we are going to carry out a certain activity, and by doing this activity we are going to investigate about, right, we are going to investigate about the process of using crowbar and how we can make our work easy. Okay, right, then so let's see what is our activity. So in doing this activity, you will be needing, my dear children, these materials. So here we are going to identify the action of a lever. Okay, we're going to identify the action of a lever, right? How does the lever is going to act, right? What are the key points? We'll be investigating about that thing over here. So here it is given, right? Let's see. So materials, first of all, we'll be needing a book, right? We'll be needing a book. Then, my dear children, we'll be needing a spring balance, or else a Newton balance. Then a wood log, then a hook, right? So these are the materials that we need, my dear children, right? We need a book, a spring balance or else a Newton balance, a wood log and a hook. Okay, so these are the things that we need right then. Okay, then the method. Let's see how to do this thing then. Weigh the book using the Newton spring balance. Keep the wooden strip on the piece of the wood as support P to balance it. So first of all, you have to weigh the book. You have to weigh it, right? Then you have to keep the wooden strip on the piece of the wood as a support P to balance it. So I'm going to take the slide somewhat to the next one in order to show that figure, my dear children. See, so this is our wooden log, right, or else the tabletop. So you have to keep that wedge like over here in order to support it. Okay, then this is the book which been placed. Then these are the hooks. Okay, distance between this wedge to the book is named as A. Distance between wedge to the force which is applied on the hook is given as X. Okay, I hope that you got the idea, right? So the first point means like this, my dear children. Weigh the book using the Newton spring balance. It's very simple. Keep the wooden strip on a piece of a wood, right, as support P to balance it. So you have to keep the wood log on the P point or else the P wedge. You can use a tabletop for it. Then, my dear children, you have to balance it like this. Okay, right. Place the book on the end of the strip. Couple the Newton balance to the other end of the strip using a book and pull the balance vertically downward. Actually, it should be hook, right? Using a hook, not book. In your textbook also there is an issue. It should be hook. Right. So, place the book on the end of the strip. Couple the Newton balance to the other end of the strip using a hook and pull the balance vertically downward, holding its stem. Take the reading of the balance. Now what do you have to? Now I'll use the diagram once more. So you have to keep the book like this. Then you have to apply the Newton balance onto a hook. Then you have to drag it like this and you have to get the reading of the Newton balance. Quite simple. Then keep the distance from the book to the support at a constant end. Take several readings by changing the distance from support to the place where the balance X is coupled. Now, my dear children, what do you have to do? So, what we need to do is we need to change the position of the hook, right? We need to change or else you can use different hooks with different lengths like this. So you have to change the position of the hook, I mean the distance between the point of application of the force and to the wedge over here. That means this x distance should be changed from time to time. And for each and every x distance, we have to take a certain reading by using the spring balance in order to lift the book which is over here. Okay. So if you want, you can use the same hook, or else you can apply several hooks like this according to the figure. Then what you have to do, my dear children, right? From a certain point, you have to apply a certain weight or a certain force. Then you have to drag it along. Then observe how much is the force needed to lift the book. Okay. Then, my dear children, you have to repeat the same step, but by changing the distance between the wedge and the hook. Okay. This is how to do the activity. So try to get at least 3 set of pairs, right? 3 set of values, right? Try to get at least 3 set of values by using this method, my dear children. And remember, it's important to keep this A distance. What is A distance? That is the distance between the book and the wedge point, which is P over here. You have to keep this distance a constant. You can't change it. Okay. So by keeping this distance as a constant, what you have to do? You have to apply force at the other end. Then you have to measure the distance between the point of application of the force and the wedge. Okay. So this is how to do. You try with three different locations, at least 3 different locations, and get a certain idea and get a certain readings, right? Like what is the way of changing the force which we need to apply to lift the book which is placed at the other end. Okay. So I hope that you got the idea. So let's head on to see the method once again. The next point. So keep the distance from the book to the support at a constant and take several readings by changing the distance from the support to the place where the balance x is coupled. Take several readings by keeping the value of greater than a and less than a. So greater than a and less than a means, my dear children, here now we have to use a somewhat certain long wooden log, or it's a long wooden strap, right? Long wooden strap is somewhat, like convenient in this activity. So our aim is to get several answers or several values. Some should be greater than a and some should be less than a. A means the distance between wedge and the book. Okay, right? So this is the way of doing the activity. Then now when you're taking the readings which we need to apply to lift the book, right, you have to reduce the distance, that means x distance, and you have to increase the x distance up to a certain level. So by changing the distance, you need to get at least three set of values, 3 set of readings by using the spring balance. Okay, right then. In each situation, observe the movement of the place attached to the wooden strip when the book lifts a vertical distance comparatively. Measure the distance x and keep records. So you have to measure and you have to keep the records. So when I'm doing the activity, my dear children, I'm going to show my readings for you guys. Okay. So it's important to record out these things. Okay. Make sure you note down these things, my dear children, and compare the values. Compare what will happen with the increasement of x length. Okay. So remember, x length is the length between wedge and the point of application of the force that we need to lift the book, right? So this is the way of doing the activity, my dear children. Okay. So I hope that you got the idea of doing the activity. Once again, I'll explain by using the diagram. So this is our diagram. First of all, you have to keep that wooden log or else the wooden strip on the tabletop like this, then you can give out a support, or else you can place a wedge like this, so that it will balance. Then my dear children, you have to place the book from the other side. Then without changing the distance between wedge and the book, you have to apply forces at the other side of the wooden strip or the wooden plank, right? Then my dear children, remember, you need to change the positions of the, right? You need to change the positions of the hook which is over here, right? So by that way, you have to take at least three set of values, right, which we needed to lift the book upward. When you are taking these three set of values, take one set somewhat further away from the wedged point, okay? Take another set somewhat closer to wedged point. Then take another value somewhat very closer to the wedged point. Like that way, you can take three set of values and compare those values, I mean the readings in the spring balance, right? And check what is the easiest, right? What is the easiest position to, I mean, like, to do the work quite easily, to lift this book quite easily. What is the point that we need to apply the force? Okay, right? So this is our activity. So how we can identify which one is easier? So if the work is going to be easy, then the force that we are going to apply is also going to be reduced. So the point where less amount of force is being shown is the point which is giving out a more efficient, or that is the point where force should be applied to do this work quite easily. Okay, so this is the way of doing the activity, my dear children. I hope that you got the idea of doing the activity quite well, right? So now let's head on to the laboratory. We'll do this experiment, and once again we'll come back to the classroom to identify the observations and the conclusions. So my dear children, to demonstrate the action of a lever, I have prepared a system over here. So you can see there is a wooden bar placed upon a small bit of another wooden stake, and I have prepared this system by using two stands. Now there is a sheet, a surface to place the small bit of this wooden stick, and also to place the wooden bar over here. Now at the other end, you can observe there is a book, and I have prepared three hooks. This hook is somewhat near to the stick which is over here. This is the second one, somewhat far, and this is the third one which is furthest. Okay, so there is a spring balance, and by using the spring balance, you know that we can measure the amount of force that we need to apply to lift off this book. Okay, so my aim is to check which hook will provide the least amount of force. You know that this book, or the weight of the object, is not going to change if I'm going to keep it in the same position without changing it, right? So I'm going to place this thing in each and every hook which is over here. Then I'm going to push it down and measure a certain value which is needed to lift off this book. Okay, the value of the force. Okay, so now the spring balance is in the closest one, which is near the stick, right? This is the stick which is being placed. Now this one is somewhat near to it. So I'm going to apply a force now, and I'm going to turn this thing down. You know that when I'm turning this thing down, or else when I'm pushing this thing down, this side goes up. So we'll find out which one or which place will produce which place will give out the least amount of force needed to push the book, needed to lift the book down upward. Okay, so in that so we are going to push it downward. Okay, so we'll see which one will do the work with ease. So this is the first hook which is closest to the stick. We'll put a pause and we'll observe whether we can get it done within a minimum force or not. Okay, so I'm going to push it now. You can see the spring is moving downward gradually. So now it's getting lifted gradually. So I'm going to lift it even more. Right. Now you can observe it's around 3.7. 3.7, my dear children. Right. Our reading is 3.7. Observe clearly over here. Right. Then I'm going to move to the next hook, which is somewhat far away from the stick over here. Okay. Now I'm going to once again apply a push downward to lift the book up. As you can see now, with a very less amount of force, I can lift it. Okay, observe the value, my dear children. If you observe it clearly over here, if you observe it clearly, then the value is around 2.3. The value is around 2.3 Newton, my dear children. Earlier it was 3.7 Newton, but now it has been reduced up to 2.3 Newton. Right, 2.3 Newton then. Then to the furthest one. So 3.7, 2.3. You see the third one. Here we go then. Let's apply a push. Observe the value carefully. Observe the value, my dear children, carefully. It's 1.8 now. Earlier it was 2.3. Now it has been reduced up to 1.8. Okay, it has been reduced up to 1.8. So 1.8 Newton is the least amount of force, right? So by that way we can come into a conclusion that, see, when the lever is somewhat, the force that we are going to apply is somewhat near to the rotating place, which is over here, this piece of wood stick. Okay, so when it is somewhat closer to it, we have to apply more amount of forces to lift the book, the same book. However, if it is somewhat further away from the rotating point, which is over here, then we can, we can within a least or within by applying very less amount of forces, we can lift the book or we can lift the weight without any trouble, right? So from this activity we can come into a conclusion that, right, when we apply less amount of forces, right, when we apply less amount of forces to a certain point of a lever, but however the point should be somewhat far away from the rotating point of the lever. Okay, so by that way, by applying very least amount of forces, we can lift the vehicle, we can lift the books without any trouble. Okay, so here once again, can you remember, here it's around 3.7, then was reduced up to 2.3, then once again was reduced up to 1.7, 1.8 Newton of forces, right? So that means, my dear children, when we are moving further away from the rotating point of the lever, then we can, by using or by applying least amount of forces, we can lift the objects or weights which are at the other side of the lever. Okay, right then. Now let's head on to the classroom once again to observe the other things contained in the lesson. Right, my dear children. So we conducted the activity in our laboratory and you could clearly observe that. So let me take you to the previous diagram once more, right? So you can clearly observe that when the distance between wedged point and the point of application of force is greater, when it is higher than the distance between weight and the wedged point, then my dear children, in simple I can say that when x is greater than a, then my dear children, by applying a very less force, we can lift the book without any trouble, right? That is the observation which we took. Okay, my dear children? So, we can say that under the observation, when the x length is greater, it's easy to lift the book, right? It's easy to lift the book because less force is needed to lift it. Okay, right then. So, we'll write down the observation, my dear children. Quite simple. When the distance between P means the wedged point, right? See over here, P is the wedged point. When the distance between P and the force applied I'll mention as position. Right. So when the distance between P and the force applied, position of spring balance is greater, force applied to lift the book is less. Right. So my dear children, this is our observation. When the distance between P and the force applied, so P means the wedged point. You can see it once again over here. See, P point is the wedged point. So from the wedged point to the place where the force is being applied, that means at the position where the spring balance is being placed. So when this length is going to increase, when this length is greater, then by applying very less force downward, we can lift the book upward. This is our observation, right? So here it is given once more. When the distance between P and the force applied, position of the spring balance, is greater, force applied to lift the book is less. So when the distance between the force applied and the wedged point is greater, less force is being applied to lift the book. So what is the conclusion that we can take from this activity? Quite simple, no? By using this instrument means the lever, by applying a less force means force which is lesser to the weight of the object, okay, we can lift it without a trouble, which means lever is going to make our work easy, right? So this is our observation. So we can conclusion, right? This is our conclusion. So we can write the conclusion then. Very simple. Higher the length, higher the length, right? Higher the length, or else we'll mention as distance. Distance is convenient now. Higher the distance between higher the distance between so higher the distance between wedged point and the force applied, the work can be done, or else we can write it in very simple manner. The work becomes easy in a lever, or else when using a lever, right? Right, so this is our conclusion, my dear children. What is the conclusion? Higher the distance between wedged point and the force applied, the work becomes easy when using a lever, right? So higher the distance between wedged point and force applied. Okay, in simple we can write it as like this. I'll take the slide somewhat up. Within brackets I'll include when x is greater than a, right? Work is easy. So what is a and x? Can you remember a and x? So let me take you to the previous slide once more to show the a and x. See, this is x, distance between wedged point and the force applied. This is a, distance between wedged point and the load, or else the book, right? The mass that we need to lift off. So when the distance between this means from the wedge point to the load, right? When that distance is lesser than the distance between force applied and the wedged point, we can do this work quite easily. That is the final conclusion that we took from this activity. See? So higher the distance between wedged point and the force applied, the work becomes easy when using a lever. That means, my dear children, when x is greater than a, work will get easy. Okay, the work will get easy. So this is our final conclusion from the activity, right? Okay then. So then given, you may have observed that force necessary to lift the book is less than the weight of the book when x is greater than a. Here, lever helps to ease the job. So like we said, my dear children, can you remember, when the distance x is greater than a, then my dear children, what will happen? We can lift the book by applying a lesser force than the weight of the object. Okay, that means, my dear children, lever is going to ease the work. Lever is going to reduce the amount of force that we need to apply, right? So when, however, when this is only applicable when the distance between the wedged point and the force applied is greater than the distance between the load and the wedged point. Okay, so this is our final conclusion then. So here once again given, when x is smaller than a, the force necessary to lift the book is greater than the weight of the book. But in this case, the book moves further than the point where balance is attached moves. This distance is advantageous in some instances. So here, my dear children, if it is getting reduced, I mean like what will happen when x is smaller than a? Then, my dear children, the opposite of that thing. What is that? Then the force necessary to lift the book is greater than the weight of the book. So in that case, we have to apply high amount of force, even a force which is greater than the weight of the object. I mean like, if the weight of the object is like 5 Newton, then we have to apply like 6, 7, 8, I mean like value which is greater than the weight of the object. Okay, right? But however, this is only observed when the distance between the load and the wedged point is greater than the distance between wedged point and the force applied, okay, on the lever, right? So but in this case, the book moves further than the point where balance is attached moves. This distance is advantageous in some instances. So this is also advantageous in some instances, my dear children. Okay, right then. In all above instances, the force applied on the lever is downwards to lift the book upward. This change of direction of force is also another advantage of a lever. So, can you remember when we are applying the force, when we are going to apply the force on the lever, we applied the force downward, not upward, right? So, it's quite easy to apply a force downward rather than applying a force upward. So, when you're moving a certain object at your home garden, my dear children, you can place a crowbar, then you can, jump into the crowbar at the other side, from the other end, so that it will move to a different location. But you have to do it very carefully, right? Okay. You can, like by using your leg, you can push downward the crowbar without using your hands. You can, push the crowbar by using your legs even. So the work is getting quite easier. Why is that? Because over there, by the application of lesser force, we can lift it downward, right? I mean like we can push the crowbar downward, and also pushing downward is quite simple rather than pulling it upward. So both the things is observed within a lever. What is that? Force which is needed to lift the weight is also getting reduced. The direction of the force that we need to apply the force, okay, the direction of the force which we need to apply is also getting changed, and the direction and the force can be applied to a much simpler and to an easier direction rather than applying it to a direct direction. Okay, so by application of a lever, or by by placing a lever, we can get both of those advantages. So that is why, my dear children, lever is this much powerful. Can you remember when we are discussing the previous chapter, I told you about that great scientist Archimedes, who told that even with a proper lever, right, we can move the planet Earth to a different location. So that much of a advantage can be observed within a lever, right? Okay then. So remember, the lever can be utilized to make our work easy, but however, when using the lever, the distance between wedged point and the load should be less than the distance between wedged point and the force applied. I mean the distance between force applied and the wedged point should be very high than the distance between the load and the wedged point. By that way only we can ease the work. Otherwise, it will go the other way around. Okay, right then. So, let us consider the previous activity. So, now my dear children, we are going to identify about the parts of a lever. Now, can you remember when I was talking about the previous case? I told you about the load, the thing called load. L-O-A-D, load. Okay, not L-O-R-D, L-O-A-D. That means the mass in simple, the load. So, like that, there are actually 3 parts contained within a lever. So, within this part, within this lesson part, now we have identified how the lever is going to make our work easy. No, we discussed that when the distance is greater between the wedged point and the force applied, the lever is going to ease our work. And also, my dear children, lever is going to change the direction of the force applied. Then by also, lever help us to make our work easy. Okay, so those are the two main key points that we can observe within a lever. Now within this part, my dear children, will be investigating about the parts related to a lever. In a lever, what are the main parts, right? What are the main things that we can observe? So once again, we are going to recall the previous activity then. Okay, so you are given with a diagram even. So let's see. Let us consider the previous activity. Here, the wooden strip is used as a lever. Now, the wooden strip or the wooden log is the one which we used as the lever. Right? Lever means, my dear children, actually, it's just a simple strip. But it should be a stronger one. Nah? Otherwise, when you are applying a force from here, then when there is a object like here, a load or else a mass, when you push it like this, then from here, it will break down. Okay, from here, it will break down. So, you won't be able to use a very simpler strip. It should be very strong and a hard one. It should be a very strong and a hard one. Okay, remember that. Right then, so this strip or the wooden log is the one which is referred as the lever. Then you have to wedge it, right? You have to wedge it first, right? So, when wedging, it's important to wedge it somewhat near to the, right? Somewhat near to the load. By that way, you can reduce this A distance and you can increase the X distance, right? By that way, we can ease our work. So, here it is given. Here the wooden strip is used as a lever. So, let's identify the 3 main parts related to a lever now. Here it is given by a highlighted color. See, the force applied on the lever downwards is known as the effort. Force applied on the lever downward, effort. So my dear children, this is called as the effort. See, the force which is applied downward, this is the effort. Right? Force applied. This is called as the effort. Effort. Right? Effort. Then the lever lifts the weight of the book. Thus, weight lifted by the lever is the load. The second fact, my dear children. Now, lever is being utilized to lift a certain weight, no? Only we use the lever to lift a certain mass or else weight. So, this weight which is being used to lift by using the lever, this is referred to as the load. The load. Right? You know that load is acting downward because it is a weight, right? So, the weight of the book is the load over here, W, weight. Then, load is balanced by the effort other the wooden support. The point of the wooden strip that contact with the lever is called the fulcrum. So the load is balanced by the effort other the wooden support. Now you know that in the wooden support the load is being balanced by the effort. Now the other case is that the point of the wooden strip that contact with the lever is called as the fulcrum. So lever is getting contact with a certain point, which is the wedged point, my dear children. So over there I have marked that thing by using the name called wedged point. So this wedged point where the lever is getting contacted with the surface is referred as the fulcrum. So this is the fulcrum, right? Point P over here, this is the fulcrum. So this point, this one over here, this is the fulcrum, right? Fulcrum. So my dear children, we can identify three main types or three main key points related to a lever. These are the main parts of a lever. So what are the three main parts? The force which is applied to lift the weight at the other side of the lever is referred as the effort. This is the effort. The point where the lever is getting contact with the wedged point or the wedge is referred as the fulcrum. From the wedged point at the either sides, the force and the load is getting balanced. Okay, fulcrum. Then the third one, the load. It's the mass or the weight which has been placed at the other side, which we need to lift off. The load. So I have named that thing by using W because it is weight. So effort, fulcrum and the load, these are the three main parts related to a lever. The three main parts related to a lever, my dear children. So I hope that you got the idea about the main parts of a lever. Once again, we'll recall the force which we need to apply to lift the load or else the weight is referred as the effort. The point where the lever is getting contacted with a wedged point or else the point where the load and the effort are getting balanced is referred as the fulcrum. The weight which is placed at the other end which we need to lift off is referred as the load or else the weight of the object. Load is the correct one. Okay. So these are the three main parts of a lever: load, effort and the fulcrum, right? Okay then. So here we have considered 3 points of a lever. Load is at one end of the lever. Effort is at the other end. Load is balanced by the effort over the fulcrum. So like we discussed, my dear children, load is placed at one end. Effort is at the other end. Load and effort, the two facts are getting balanced or wedged, especially through a certain point. This point is the fulcrum. So the specialty in fulcrum is that, my dear children, when applying a certain effort, right, fulcrum helps to rotate the lever and to lift the weight. Is it rotating or just moving? It's not going to rotate, no, just moving downwards. Ne? Is that so? Actually, it is going to rotate, my dear children. By applying a certain effort at the other end, we are giving out a certain moment Moment means the rotational effect of a force. So you'll be learning about this moment in detail when you go to the next grade, grade 10. Actually, what we are doing is here, by applying from this side, we are rotating it to a different location. I mean, like, I'm going to rotate the lever downward, right? Actually, when the person is applying a force on this particular place, the lever is going to rotate like this. Through the rotation, the weight which is placed over here is going to rotate and come to the other direction. That's why it is being lifted off. Okay. Actually, within a lever, my dear children, the fact called moment of a force can be observed. Moment means the rotational effect of a force. Okay. The rotational effect of a force. So, let me give you another simpler example where we use this lever thing. When you are going to open a certain door, you know that the door handle is at the far end corner, right? Rather it is being placed near to the hinges. Why is that? This is also somewhat similar to the process of lever, my dear children. If the handle is closer to the hinges, my dear children, then what will happen? Distance between the rotation point or the hinges to the handle of the the door wheel or the door handle is less. That means we have to apply heavy force to open the door. However, if the distance between the fulcrum means the rotation point, from the rotation point, right, if the distance is somewhat greater to the point of force applied, then, my dear children, through application of a very less force, we can open the door. That is why actually the door handles are being placed somewhat away from, right, actually far away from the rotation point, which is the hinge, right, hinge of the door. So it is very far away from the hinges of the door, right? The door handle is very far away from the hinges of the door to make our work easy. The same process can be applied or same process can be observed within here also. When this length is high, my dear children, we can rotate it very quickly, like the door. When you are opening the door, you know that door is going to rotate here and there. So by application of a very less force, we can rotate the door without any trouble. However, the distance between the rotation point and the place where we are going to apply the force should be somewhat higher. Okay, that's how we apply a certain less amount of a force to rotate the door. The same process can be observed in here also. So when you elongate this or when you extend this arm, right, when you extend this arm, the length between the fulcrum and the effort, by applying a very less force, we can do our work. That's why Archimedes told that if he is given with the proper lever, then he even can move the planet Earth, my dear children, right? Imagine a very big lever having a very greater distance between the fulcrum and the effort, right? We're going to place it like to the planet Earth. We're going to place it. Then from the other end, just by pushing our finger, we can lift it off, my dear children. It's because that's how this rotation works. That's how this machine works. The lever, right? Higher the length, the work is much easier. What length? The length between the fulcrum and the effort. So here also, my dear children, we can observe a rotational effect like in a door. Okay, so you will get to know about rotational effect when you go further with the lesson part, my dear children. Actually, not within this grade, but however, when you go to grade 10, you will learn about this moment of a force in detail and even how to calculate these things, right? Okay, So I'm going to remove these things then. Let's see once again. So here we have considered the 3 points of a lever. Load is at one end of the lever, effort is at the other end. Load is balanced by the effort over the fulcrum. So effort is at one end, load is at the other end, which is the weight of this thing. And these two are well balanced by the thing called fulcrum. Okay, fulcrum. So fulcrum is the one which is going to help to balance the load and the effort, my dear children. And the other thing is that from the place where the fulcrum has been placed, the lever is going to rotate here and there. Okay, from this particular axis or through this particular axis, the rotation is observed. That means, my dear children, when the person is applying an effort downward, it is going to rotate like this. However, along this particular point through the fulcrum, right? So fulcrum is the point where the effort and the load is being balanced within the lever. Then let us consider the lever shown in the figure. AB is a metal rod. Now I told you that, my dear children, now we are using a lever now. When using a lever should be very strong, otherwise it will break down because you are applying a certain force over here, and if it is not strong, even if it is not going to break, then it will bend. So we won't be able to use it once more. Okay, so we have to use a very stronger one. Metal one would be perfect, like steel or iron. Steel is the one which is the hardest. So steel, using a steel crowbar or else using a steel lever is good. Okay, because it is having a good strength. So we can lift large objects by using a steel lever. Okay, so here there is a lever given in the diagram. As given here, the AB rod is a metal rod. Effort is applied downwards at B. So from B or at B, an effort or else that is the force which is applied downward. So a downward force is applied on B, which is called as the effort. So this is the person who is applying that force. Okay, the effort. Then rod is balanced on C. So C is the fulcrum. Now this rod, okay, or the metal rod or our lever is getting balanced on the point C. So this point C is the fulcrum. So as you can see here, C is the fulcrum, B is the effort. Now my dear children, the third one, the load. A is the load, my dear children, where the object has been placed. Okay. So the part of the lever from the effort to fulcrum, CB, is known as effort arm. The part of the lever from load to the fulcrum, CA, is known as the load arm. We can identify two other factors. The distance between fulcrum to the effort. Okay, distance between fulcrum, that means the point where the lever is going to balance. From that point, the point where the force has been applied, there is a certain distance, there is a certain gap. So this gap between the fulcrum or the rotation point and the effort is referred to as the effort arm. Effort arm. So CB is known as effort arm, my dear children. This is known as the effort arm. Effort arm. Then next one, see, the distance between fulcrum, that means the point where the lever is getting balanced or the point where the lever is getting rotated. From this point, right, the distance to the load from this point, the distance to the load or the place where the weight has been placed. So this is referred as the load arm. This gap or this distance is the load arm. So load arm is the distance between the load, right? It is the distance between the load. Load means the weight which we need to lift, and the fulcrum. Distance between the load and the fulcrum. Fulcrum is the point where the lever has been balanced. So this particular length is called as the load arm. Can you remember, my dear children, when we are discussing the previous activity, I told you about the load arm. I didn't mention about the load arm and the effort arm, but however, I told you that distance between the wedged point to the point where the force is being applied, the distance between wedged point to the point where the weight has been located. Can you remember? When increasing this length, this is the effort arm. Can you remember? Right? When increasing this length, it's quite easy to utilize this lever. By applying very less amount of force, we can lift off that object. So lever is very beneficial when the effort arm is greater than load arm. When the effort arm is greater than load arm, lever is very beneficial to us. Without applying a force equal to the weight of the load, we can lift off the load, or else we can lift off that particular weight, right? In simple, if the weight is around 20 Newton, right? If BC is greater than AC, then if I am going to take this force as F, then my dear children, the force which is applied on F is definitely less than 20 Newton. Okay. However, in order to observe that, the BC length means the effort arm, should be greater than the AC length, which is the load arm. If that's so, then the force which is applied by the person is less than 20 Newton, which is the weight of the object. So in simple, that means, my dear children, the 2 kilogram of a mass can be lifted off by this person, right? Or else by the other side, by placing an object which has a mass less than 2 kilograms. Okay. You place 2 kilogram of a mass over here, then you take the lever so that the BC length or else the effort arm is greater than the load arm. Then just by placing a simpler mass less than 2 kilograms, you can lift off the 2 kilogram mass which is placed at the other end. This is how the lever is going to work. However, lever is beneficial only when the effort arm is greater than the load arm. Okay, my dear children. So I hope that you got the idea and you got a good sound knowledge about the parts of a lever and how to utilize this lever in our day-to-day activities. Okay. Always remember, effort arm should be greater than the load arm. If so, the lever is beneficial to us. Right. So my dear children, here you can observe a typical lever. Now levers are used to make our work easy. You know that if you take a machine, you know that machines are going to make our works easy. So these things are very simple machines, my dear children. So this is a simple lever that you can observe over here. Now you know that within each and every lever, my dear children, there is a certain weight that we need to lift. So this is that weight. So weight is placed at the one end of the lever. Okay. Then my dear children, within this certain point over here, you can observe that the lever is going either up or else down. See. So around this point, the lever is going to turn up or down. That means it's going to rotate up and down actually. Now you can see that if I'm going to apply a force over here, then it will lift. In here, actually when I'm applying a force over here, it will going to turn and travel like this way, right? It shows a clockwise rotation. This one shows a clockwise rotation. So actually in a lever, what happens is when applying forces, it will tend to rotate, my dear children. Okay, so here you can observe the rotating point. This is the rotating point, my dear children. So we have fixed the bar over here. So within this or around this point, the lever tends to rotate. And this is the place where we are going to apply force to lift the weight placed at the other end. Okay, at this end we are going to apply the force. Okay, so we can observe three main parts in a lever. The first part is this one. This is the place where we apply a certain weight. So this is referred as the load. This is the load. This is the place where the rotation is going to start, the rotating point. So the lever start to rotate, or it will move from this point. This point is referred as the fulcrum. Fulcrum. The place where we apply the force to lift the weight upward is referred as the, this is the one which is referred as the force, right? This is the place where we apply the force in order to lift the weight. Okay, so at the place where we apply the force, the amount of force is referred as the effort. So load, fulcrum and the effort. Load, fulcrum and the effort. So these are the three main parts that we can observe within a lever. So according to the position of the load, fulcrum and the effort, there are several kinds of levers too. However, we will be studying those things within our next activity. Okay, now let's once again head on to the classroom and we'll observe other things related to these levers. Right, my dear children. Now let's head on to see the next content. You are given with a certain topic called the mechanical advantage. Mechanical advantage. The mechanical advantage means how much is the lever is beneficial to us. This is showing like the benefit of using the lever, my dear children. The mechanical benefit. So this benefit is measured as a ratio. It is measured as a ratio. So this mechanical advantage is equal to, very simple, load division effort. It is equal to load over effort. The effort. Right? So just by giving out this, mechanical advantage as a formula, you won't be able to get an idea. So let's see the example given here. It is given, if a load of 36 Newton is lifted by applying an effort of 12 Newton, then the mechanical advantage is, now here it is given, load of 36 Newton, 36 Newton load of, right, load, that means a weight of 36 Newton can be lifted off by applying a force of 12 Newton effort. Then the mechanical advantage, let's see. So mechanical advantage equals 36 Newton division 12 Newton. You know that Newton to Newton is getting cancelled off when you are dividing a certain value that has same units. So when same units are getting divided, those two units are getting cancelled off. So you know that here 12 times 1, then here 12 times 3. So our answer is 3. So what's the meaning of this 3 then? Actually, this 3 indicates that 3 times. What do you mean by 3 times then? It means, my dear children, this is 3 times beneficial. The mechanical advantage is 3 times, which means by using this particular lever, my dear children, you can lift a certain object that has the 3 times weight than the force which is being applied. You can see it even in the question. By applying only 12 Newton of a force, we can lift off 36 Newton. That means the ratio between effort to the load, is 1 to 3. By applying 1 Newton of a force, we can lift 3 Newton of a force at the other side. So mechanical advantage is the ratio between load and the effort. Okay, if the mechanical advantage is at least greater than 1, then the lever is quite beneficial to us. That means, my dear children, without the application of weight of the object or weight of the particular load, by using a very less amount of force than the load, we can lift off an object by using that particular lever. If the mechanical advantage is greater than 1, only if the mechanical advantage is greater than 1, then lever is quite beneficial. Okay, so this is the mechanical advantage. So mechanical advantage implies like how much of a load can be lift off by applying that particular force. Here 3 means 3 times of the force applied. That much of a weight can be lifted from the other side. In simple, when applying 1 Newton of a force from the effort side, you can lift 3 Newton of an object from the load side. This is what do you mean by the mechanical advantage. So I hope that you get the idea about the parts of a lever, my dear children, and about the mechanical advantage. Okay, so from that one, my dear children, I'm going to finish up this chapter. We'll be learning about the levers in even more when you're going with the next chapter, my dear children. Over there we'll be discussing about several types of levers with several orders. Okay, there are several orders of levers. By changing the fulcrum, changing the load, by changing the fulcrum means changing the position of the fulcrum, load and the effort. There can be 3 types of orders or 3 types of levers. So in the next chapter we'll be learning about these types of levers specially. Okay, so I hope that you got the idea about the main parts of a lever and how the lever is getting beneficial to us when we are doing our day-to-day works. Okay, right then, my dear children, so we'll discuss further things related to the lesson part, especially with the levers thing in our next chapter then.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.